Have you ever noticed the distinctive hissing, crackling, and glowing effect emanating from high-voltage transmission lines and transformers? Are you still unsure what causes this phenomenon? Allow me to enlighten you. The answer lies in a fascinating electrical occurrence known as corona. What is corona? Corona is a phenomenon that occurs when a high-voltage electrical discharge ionizes the air around a conductor, creating a glowing, hissing, or crackling effect. This discharge is often accompanied by a faint blue or purple glow, which is why it's called corona. Corona occurs typically in a high-voltage electrical system of 100 kVA and above. Corona occurs when the electric field around a conductor becomes strong enough to ionize the surrounding air molecules. This creates a plasma of ions and free electrons that can conduct electricity. Forms of corona discharge. 1. Visual corona, a visible glow or discharge around the conductor. 2. Audible corona, a hissing or crackling sound accompanying the discharge. 3. Radio frequency corona, a high-frequency electromagnetic radiation emitted by the discharge. Various electrical systems corona can occur. 1. High-voltage transmission lines. Corona can occur when the voltage difference between the transmission line and the surrounding air is sufficient to ionize the air molecules. 2. Power substations. Corona can occur in substations where high-voltage electrical equipment is present. 3. Electrical equipment, e.g., transformers, switchgear. Corona in transformers can occur due to high-voltage stresses, insulation degradation, and moisture ingress. 4. Insulators and bushings. Corona can occur due to high-voltage stresses, poor insulator design or manufacturing, contamination or pollution, aging or degradation of the insulator material. 5. Generators and motors. Corona can occur in the windings of generators and motors, particularly if the insulation is damaged or deteriorated. Factors affecting corona. Environmental factors. 1. Temperature. Corona can occur more easily at high temperatures, as the air molecules have more energy and are more likely to ionize. 2. Air pressure. Corona can occur more easily at low air pressures, as the air molecules are more spread out and can ionize more easily. Geometric factors. 1. Conductor spacing. Corona can occur more easily when conductors are close together, as the electric field is more intense. 2. Conductor surface roughness. Corona can occur more easily on conductors with rough surfaces, as the roughness can provide a pathway for electrical discharges. Electrical factors. 1. Voltage. Corona can occur more easily at high voltages, as the electric field is more intense. 2. Frequency. Corona can occur more easily at high frequencies, as the electric field is more rapidly changing. 3. Insulation. Corona can occur more easily on conductors with poor insulation, as the insulation can provide a pathway for electrical discharges. Material factors. 1. Conductor material. Corona can occur more easily on conductors made of materials with high electrical conductivity, such as copper. 2. Insulation material. Corona can occur more easily on conductors with insulation made of materials that are prone to electrical discharges, such as some types of plastic. Positive effects of corona. 1. Reduce the risk of electrical discharges. Corona can help to reduce the risk of electrical discharges by dissipating the electrical energy before it builds up to a dangerous level. 2. Improve the efficiency of electrical systems. Corona can help to reduce energy losses in electrical systems by allowing the electrical energy to be dissipated more efficiently. 3. Reduced ozone generation. Corona can help to reduce the generation of ozone, which is a harmful gas that can contribute to air pollution. 4. Diagnostic tool. Corona can be used as a diagnostic tool to detect electrical discharges and other problems in electrical systems. Negative effects of corona. 1. Energy loss. Corona can cause energy losses due to the ionization of air molecules. 2. Noise and interference. Corona can generate electromagnetic interference, EMI, and radio frequency interference, RFI. 3. Equipment damage. Corona can cause damage to electrical equipment and insulators. 4. Safety risks. Corona can pose safety risks to people and animals nearby as it can create a shock hazard. Techniques used in mitigating the negative effects of corona are: 1. Increasing the conductor diameter. 2. Using corona-resistant materials. 3. Applying corona-suppressing coatings. 4. Optimizing the electrical system design.